Hey everyone, today we're going to be covering Concat and Append methods for Pandas data frames. So basically I'll be showing you how to concatenate and append multiple data frames in several different ways. So it's best if you follow along with me using this Python notebook that I have open up right now. You can open this up in Jupyter Notebooks or Google Colabs. I have mine open in Google Colabs. So everything you'll need, such as the download link to this notebook, as well as exercises and solutions in case you want to practice more, all of that is linked below in the description. Okay, let's get started. So I will start by running this code block here. This code block is essentially a class called display, which will help display multiple data frames, multiple objects side by side. So we're going to be using this a lot in this notebook. So just run this line of code just so it's in memory. We're going to import our standard libraries, import NumPy as NP and import Pandas as PD. So we're going to be using libraries from NumPy and Pandas. So, with every notebook, every Python notebook, I almost always will be importing these two libraries. So make that a habit for yourself. All right. So now what I want to do next is I just want to run this line of code as well. This is a function that will make a data frame very quickly. So this is the function right here. This is an example. I called this function make df, and then all I'm doing is basically entering in the column names as well as the data. So if I run this line of code here, ABC are my column names, just like it's written here. And the range is essentially 0 to 1, or basically three elements. So I have 3 rows here, and so that's exactly what I'm expecting from this function. So go ahead and run this code block so that we can leverage make df in future exercises. So after all that, I think we're ready to get started. So we're going to start with some simple concatenation with this concat method called pd.concat. Essentially, this is what it looks like here. This pd.concat has all of these parameters that you can leverage in this method. We're going to cover most of it. We're not going to cover all of it, but in the simplest terms, essentially all you really need to do is put in your objects or put in your pandas data frames or pandas series, and that's all you would really need to use the concat function. So let's actually get started with a really simple example. I'm going to create 2 pandas series here, series 1, series 2, and if I execute that line of code, let's now display what it might look like. This is series 1, right? I'm just going to replace the 1 with a 2. This is series 2. So basically it's an index of 1 through 3, ABC, and then the second series is an index of 4 through 6, and a series in value of DEF. So if we want to concatenate that, all we need to do is call the concat function. So what we're going to do is we're going to type pd from the pandas library concat, and then what concat needs is a list of objects, right? And so to create a list, you need brackets. So we have the square brackets first, and then I'm going to type in ser1 and then ser2. So basically, using the pandas concat function, concat series 1 and series 2 objects. And if I run this line of code, I get both series concatenated on top of each other, right? So concat means that It's concatenated, it's joined together, it's merged together, really whatever other synonym you want to use. But now we just have one list or one pandas series. And it goes from an index of 1 through 6 and A through F. And essentially what you have is just one pandas series now. So that's the simplest concat example that I can give. By default, concat will be vertically merged together. So that's why you see series 1 basically on top of series 2. There are ways that we will be able to horizontally merge them together. And I'll show that in 1 or 2 examples from now. But an example I wanted to show is really how you would be able to do this with multi-dimensional data frames. Like just a higher dimensional data frame object. So let's actually go ahead and show this example. So let's just take the first data frame. We're going to call it df1. We're going to use that function that I ran above called makeDF. So I want to make basically a 2x2 data frame. I'm going to have AB, so a column with A, a column B, and then I'm going to put in values 1 and 2. So if I run this, and you know what I'll do is actually display what it looks like. I have this data frame. Now I'm going to create a second data frame. Same column names, different values, 3 and 4. And now you have basically a 2x2 data frame here. So let's concatenate this together. PD concat, and it's as simple as starting a list, so using square brackets and then typing in df1, df2. And what you should see is df1 on top of df2 joined together. All right, so actually one thing I forgot to do is use that display function, display class that we were talking about in the very beginning and at the very top of the Python notebook. So another way of just making everything look a little bit better, just for your sanity, is to use this display function or display class. And maybe what we want to do is just display all of the data frames that we created and then the concated data frame. So I'm going to type in pd.concat df1, df1, df2. And we have 3 data frames side by side, which is exactly what this display function is supposed to do. And it just looks a lot nicer and a lot cleaner. So you can use this function whenever you want, just to make things look a lot nicer. So before I mentioned that PD concat or concatenation basically stacks 2 data frames or 2 data objects together on top of each other, right? Vertically concatenating. So this is called Rowwise Concat, Rowwise Concatenation. The default of that is actually access equals 0. So there's a parameter within PD concat that you can specify what access you want to merge 2 data frames together. So we're gonna actually change this up a bit and concatenate based off of axis 1 or based off of the column axis. So what does that mean? In layman's terms, it means that we're going to be merging 2 objects together horizontally, side by side. All right, so maybe I'll just make it easier and just say side by side concatenation. And the way to do that is I will first create 2 additional data frames. So we're going to have data frame 3 and data frame 4. Okay, and then what I'm going to do is I'm going to display everything side by side. So I'm going to display data frame 3 first, then I'm going to display data frame 4 next. And then I'm going to display both data frames concatenated on the column axis or axis equals 1. Right? So you have concat, PD concat, and then you essentially have the list of the objects you want concatenated, which is df3 and df4. And then I have this parameter, which is new, called axis equals 1. So just up here, it says that the default concatenation takes place on axis equals 0. So I'm gonna have axis equals 1 so that rather than the objects being vertically concatenated, I want it to be side by side. All right, so if I run this line of code, whoops, I forgot to close the parentheses here. So I have now df3 and df4 side by side together, right? So now that we know how to concatenate two pandas data frames together, we should be careful about the indices because the indices can be duplicated and that can essentially mess you up with any sort of calculation or analytics you're trying to do. So let me just show you a simple example of what I mean by that. I'm going to create two data frames, an X and a Y. And so if I display X, I'll show you what it looks like. It's a 2x2 data frame. And if I then display Y, it's another 2x2 data frame, right? It has columns A and columns B, but the indices here are 0, 1, 2, and 3. But if I then make them equal to each other, so let me just say y.index equals x.index. To just illustrate my example, let me just display y again. Y now has the same index 0 and 1 as x does. So if I chose to now concat x and y together, what I'll get are duplicate indices. So I have 0, 1, and then I have a repeat on row 3, 0, and 1. And you know, this line of code runs. It's not going to throw an error, but it's not desirable if you are doing analytics using indices. Like if you're keeping track of certain rows or certain values based off of indices, that could pose a big problem. So there are many ways to fix them. In this next section, what I'll do is I'll show you how to actually catch these errors because sometimes they just show up without you ever really realizing it. So in order to catch the error, all you would really need to do is use the verify integrity parameter and set that to true. So really all you need to do is if you want to concat x and y together and you know x and y have the same indices, all we need to do is type in verify integrity and then set that parameter to true. And if you set it to true, it should turn blue. It just is signifying that it's a Boolean data type. All right, so if I run this line of code, I'm going to get an error. I'm going to get indices that have overlapping values. And all that really means is that your indices are duplicated. So you have 0, 1, and 0, 1, and that is not really good practice. And Python will throw an error if you actually put in verify integrity equals true in the concat parameter. Another way of handling duplicate indices is to just ignore them altogether. So one way or an easy way to do that is to use the ignore index parameter. So we can do pd concat X, Y. So these are, again, the two pandas data frames that I care about. And I'm going to use the parameter ignore index equals true. So it's going to ignore the indices of X and Y altogether. And it actually kind of resets them too, right? So now it's 0, 1, 2, 3. So if your analytics, your code doesn't at all require you to keep track of the indice values, then I suggest you just ignore them altogether so that you don't have to deal with error messages that pop up because your integrity is false. So one other way of dealing with duplicate indices is to add a label to your data source or add a label to your index. So one way we can do that is add a key by using the keys parameter. So I'm going to type in the standard pd concat x comma y because those are the two data frames that we care about. The parameters keys is equal to, and I'm just gonna say one key is going to be labeled X for the X data frame, and one key is going to be labeled Y for the Y data frame. If we do that, then we get X here and Y here, and then we get duplicated indices. But because this is X0, X1, and Y1, Y0, the indices are not duplicated. So that's another way of kind of skirting the issue of having duplicate indices, is to add a label to the data source so that at the end you actually still have unique indice values. So in this section, I want to talk about joining two data frames together when the column names are different. So this is actually more of a real world example, because when you source data frames from several different data sources, most of the times the column names are not identical, right? And so how are you going to join two data sets together when the column names itself are different? So that's completely different than the examples that we just went through, because those examples, the column names were the same. So it was really easy for Python to basically join them together, because it could just join them based off of the values of the columns, right? Based off of the column names. So let's go through a simple example here. I'm going to make two data frames using the makeDF function, and I'm just going to copy and paste from my notes. So what this is going to give us is, I'm going to actually display both side by side, df5 and df6. If I do that, I get this, right? I get essentially a 2x3 data frame, but the column names are different. They're actually shared in that they have B and C as column names, but df5 has A, and A is missing from df6. df6 has column D, D is missing from df5, right? And so how are we going to concatenate them together? Or if we do concatenate together, what's that behavior going to look like? All right, so now let's just type in, well, maybe I'll start a new code block. Let's type in pd.concat. And then I want to obviously concat these two data frames together. And I'm going to just keep it as that, no extra parameters. And what I see here is I have nulls right here where data frame 5 is missing a D column, and I have nulls right here where data frame 6 is missing an A column, right? So what I'm going to do actually now is just put them side by side so that they're just a lot easier to read. And I need to add this, I need to add a string here, or quotes to make it become a string. All right, so now it's side by side. And you see this, right? When we are vertically concatenating or concatenating off axis equals 1 or axis equals 0, df5 is on top of df6. And df5 does not have a D column, and df6 6 does not have an A column, so you have null values. So this is what we're calling like an outer join, because in SQL, if you did this exact same merge or concatenation, in SQL this would be called a full outer join. So that's one reason, I guess, why the join parameter is called an outer. So just like SQL, you can actually make the join parameter an inner. And so let's look at what that looks like. So what I'm going to do now is I'm going to just display everything together. So I'm actually going to perhaps do this, just copy and paste. But then in this PD concat, what I'm going to do is add an extra parameter. I'm going to add the join parameter, and I'm going to specify how I want to join these two data frames together. So the default is outer. So if I just do outer like this, let's see, maybe I think I need to do double quotes outer. Yeah, double quotes. I get what I get above here, right? This is the full outer join that I was talking about. And if I did inner, now I get something different. Now I get only columns B and C, because df5 and df6, the two columns that they share are columns B and C. They don't share column A together, and they don't share column D. So because you have this join parameter as inner, you're only going to be saving or displaying shared columns. And this is what we get. All right, this is very, very similar, if not identical, to the SQL concept of inner joins. So just to add additional complexity to all of this, Python and Pandas have an append function or an append method, as you see here, that's basically identical to the concat method. So just to make things easier for yourself, you can append df1 to df2 just like I'm doing right now, which is going to be the same as if I typed in pd concat df1 and df2. It's the same output, different methods. I guess with the append method, you save on keystrokes because, you know, I'm not typing in PD, I'm not putting these square brackets in. And I guess when things get a little bit more complicated, it saves on keystrokes there. But it's, you know, the append method is there for you if you want to use it. You can use concat as I was teaching you before, or you can use append to join two pandas data frames.